Okay, ladies and gentlemen, now in last section we saw how to vertically shift, horizontally shift, and stretch amplitude on a trigonometric function, a sine wave in particular. Works the same on a cosine wave, and we should have gone through that by now at this point. But today we're going to do the hard bit. I want you to think about an accordion. An accordion, that thing where they squeeze it together and it makes noise like a polka band, has a keyboard on one side, okay? Because that's what we're going to be doing with this function. We already talked about how sine goes up to 1, down to -1, and it goes from 0 to 2 pi, and we have 0 here, we have pi over 2, we have 3 pi over 2. Again, do it all before you do anything. If I don't see labels, it's wrong, because it just means you're being lazy. Now, standard equation looks as follows. There it is. Now, the period we already talked about is 2 pi. But this guy right here is the frequency. Now, if I say, with what frequency do you go to Walmart? It means how often do you go to Walmart? Each separate trip counts as a trip. So let's say I went twice this week, I would say I go about twice a week. That's my frequency. If I went 3 times a week, my frequency would be 3. It's not that challenging. In this case, in sine x, there is an understood frequency of 1. It does one job in one period. But if I have a frequency of 2, that means it's going to do 2 whole cycles within one period. That means it's going to go from the bottom to the top, to the middle, to the bottom, to the top, and it's going to do it twice. So it's going to and it's all going to do it twice within the system. Now, easiest way to figure out if I have a particular frequency, what is my period? Its frequency equals 2 pi over period. In the same way, I have another equation that says period equals 2 pi over frequency. So in this case, I'm given the frequency. I can say the period is 2 pi over 2, meaning the whole thing has to fit inside pi. So if it starts here and it now ends here, I have to squish everything down. So in this case, it goes up, hits the middle, comes down. The middle used to be at pi. Now the middle, if I squish the end halfway, the middle's going to be at pi over 2. Because I have to get up to the middle, down and back to the middle, all in the space of pi. So that means this upper point isn't at pi over 2 anymore, it's pi over 4. And here, it's going to be back this way. What you're really doing is taking each of these measurements and dividing them by the frequency. So 2 pi divided by 2 pi. 3 pi over 2 is now 3 pi over 4. Pi is now pi over 2, and pi over 2 is now pi over 4. And it shortens up. That would allow us that if we chose to, we could draw both in the same period. And we've now fit 2 sine waves in the space that it used to take to just fit 1. So that is shrinking it. So ironically, as the frequency goes up, the period goes down, because to fit more in, they got to shrink. Now, I only care that you show me the first period of any shrink. Okay? Now, let's do number 2. Number 2, I want to do sine of 1/2 x. Not sure why the x has a toupee, but it does. Now, in this case, 1, -1, 2 pi, pi, pi over 2, 3 pi over 2, middle, up, middle, bottom, middle, Okay. Now, if my frequency is 1/2, that means my period equals 2 pi over 1/2, which, of course, is 4 pi. That means instead of starting at 0 and going to 2 pi, I'm starting at 0 and going to 4 pi. So here's my start, here's my end. My halfway point was divided by a half, which means doubled. And so instead of pi over 2, it's now pi. Everything stretches accordingly. And there we go. I've now expanded it this way. So by expanding it that way, because the period went down. Now, let's go a different way. First of all, I want you to do number 1. I want you to do cosine of 4x. Now that means it's going to get way shorter, just letting you know. Number 2, I want you to do f of x equals sine of, oh, let's mix it up here. Let's go 2, that's by the way your amplitude, of 1/2 sine. So see what you can come up with there. All right. Now, on the other hand, let's say they give us some information. And let's do number 3. You must have this on your page. They give us that the cosine of x is the parent, that the amplitude equals 1/2. That means it's going to be half as tall. That we have a horizontal shift of 1 left. And let's do a vertical shift of 2 down. And let's do a frequency of 2. Now, for my equation, that's not too bad. I can say, all right, my vertical shift can go first. Let me give you a general formula. C plus A trig bx minus d. By the way, you book readers, this is going to be different than your book. I know that. We're doing it this way on purpose. So, vertical shift. If you want, you could rewrite it as this. Vertical shift plus amp trig frequency x minus horizontal shift, if you like that better. So, vertical shift of 2 plus amplitude 1/2 cosine frequency 2 and x minus 1. And now I can take that and graph it, and that's what I want to see. Give me that as a graph. So graph all 3 of those.